Lesson 30 is on the circumference of a circle, and the formula that you use to find circumference of a circle is either pi times the diameter or 2 times r and then times pi. And on a circle, halfway across is r, all the way across is d. So you can see why you can either do pi times the diameter. Sorry about the noise you're probably hearing. I'm adjusting the mic here. You can either do 2 times r, which would be twice across half, which was the diameter, or pi times diameter. Number 1. The dump truck traveled north 20 miles to pick up a load of rocks. So they go up north 20 miles. Then it traveled south 7 miles to dump the load. How far is the truck from where it started? So basically what I need to do is 20 minus 7 to get this distance here. And that gives me 13 miles. A puzzle has 330 pieces. How long will it take to complete the puzzle if 60 pieces are put together each hour? Well, if I have 330 pieces divided by 60 pieces per hour, question is how many times does 60 go into 330? Well, 60 would go into 300 5 times, because 5 times 60 is 300, and I can't get another one in. So 5 times 60 is 300. And then 30 minutes is half an hour. So we have 30 minutes left over, so 5.5 hours. Sarah laughed once the first hour, twice the second hour, 3 times the third hour, etc. If this pattern continued 9 hours, how many times did Sarah laugh in all? So first hour, second hour, third hour, fourth hour, fifth hour, sixth hour, seventh hour, eighth hour, and ninth hour. And then we add this all up, and it's kind of convenient. If I add 1 and 9, I get 10. If I add 8 and 2, I get 10. 7 and 3, I get 10. 6 and 4, I get 10. And then I have that 5 left over. So 10 plus 10 plus 10 plus 10 plus 5 is 45 times. Leah will win the board game on her next turn if she rolls a number greater than 2 with 1 number cube. Find her chances of winning on her next turn. So, on a number cube, we have the numbers 1, 2, 3, 4, 5, and 6, and she needs one of these numbers that are greater than 2 to win. So 4 numbers would be a favorable outcome out of the 6 total, which would reduce to 2/3 because I can divide the top and the bottom by 2. And then it says express your answer as a ratio in simplest form, so 2/3, and as a percent rounded to the nearest whole percent. And 2/3 is a percent that you should just know. It's 66.666 repeating, or rounded to the nearest whole percent, it would be 67%. And if you didn't know how to do that, you could take 2 and divide it by 3 and get the decimal, and then you just move the decimal place 2 places to the right. In a coin collection, the ratio of buffalo nickels to non-buffalo nickels is 2 to 8. If there are 96 non-buffalo nickels, so we put that where the N is, how many buffalo nickels are there? So to go from 8 to 96, what do I have to do? Well, 8 times 12 would give me 96. So then I got to do that on the top. 2 times 12 is 24. So there must be 24 buffalo nickels. Simplify. So we have -3 times -5 times -2. So I'm just going to take them in pairs. -3 times -5. 3 times 5 is 15. The signs are the same, so it's positive. And then we have 15 times -2. 15 times 2 is 30. And then the signs are opposite, so our answer is negative. In number 7, we're going to do the top first. So we're going to do -5 times -12. 5 times 12 is 60. They're the same sign, so my answer is positive. And then my last step, I'm going to do 60 divided by -10. 60 divided by 10 is 6. And then the signs are opposite, so my answer is negative. In number 8, it looks like we're dealing with fractions, but really it's just division, because 6 can be divided by 3 and 10 can be divided by 5. So 6 divided by 3 gives me 2, and the signs are the same, so it's positive 2. And then 10 divided by 5 gives me 2. The signs are opposite, so it's -2. And then 2 plus -2 gives me 0. In number 9, when we have variables and numbers in a fraction or division like this, we ignore the variables to begin with and do just the numbers. So -12 divided by -2. 12 divided by 2 is 6. They're the same sign, so it's positive. So then I go back and I say, well, there's nothing to do with the x. There's no other variables to combine it with, so it's just x. In number 11, we have a whole bunch of mixed numbers being added and divided. So the first thing that we need to do is convert these into improper fractions. To do that, we take the whole number times the denominator. So 1 times 4 is 4, and then we add it to the numerator. So 1 times 4 is 4, plus 1 is 5. So that turns into 5/4. And then 2 times 2 is 4, plus 1 is 5/2. 1 times 3 is 3, plus 1 is 4/3. Now that they're improper fractions, I can actually do the operations. Division comes before addition. So division with fractions means multiply by the reciprocal. So I'm going to have 5/4, I haven't done anything with that. And then plus 5/2 times 3/4. 5 times 3 is 15. 2 times 4 is 8. Oops, that's 5/4 for this first one here. Sorry about that. So now I'm going to write 5/4 as something over 8 so that I can add the fractions. If I multiply the top and bottom together, so 5/4 over 8 would mean I multiply by 2. 5 times 2 is 10. So I have 10/8 minus 15/8 gives me 5/8. Oh, sorry. Adding 25/8. And then to write that as a mixed number, 25, 8 goes into 25 3 times with 1 left over. 1/5 minus 1/5 times 1/2. The multiplication needs to be done first. 1/5 times 1/2. 1 times 1 is 1. 5 times 2 is 10. I'm going to write this fraction 1/5 as something over 10 so that I can do the subtraction. To go from 5 to 10, I multiply by 2. 1 times 2 is 2, so 1/5 is the same thing as 2/10. 2 minus 1 is 1, 10 stays the same. We're going to treat the top and the bottom separately. So the first thing that we can do is 4.28 minus 1. We can add the zeros as placeholders to help us line them up. So we have 3.28 on the top. And then 2 times 0.2 is just 2 times 2, which is 4. And then we ignored 1 decimal point, so it's 0.4. And then 3.28 divided by 4. Four can't go into 3, but it can go into 32 8 times. 8 times 4 is 32. Bring down the 8. 4 goes into 8 twice. 2 times 4 is 8. So our answer is 0.82. Number 13, we have the powers that, or the exponents that come first. 5 squared is 25. 12 squared is 144. Then we can add them together and get 169, and then the square root of 169 is 13. X to the 0 times x to the 5th divided by x squared. Anything to the 0 power is 1. It's a little bit counterintuitive, so we have 1. X to the 5th is x times x times x times x times x. X squared is x times x. So these x's, since they match up top and bottom, will cancel out. We'll ignore the 1 because 1 times anything is itself, and that leaves us with 3 x's on top, so x to the 3rd. Number 15, it asks us to figure out what 2 to the 6th times 3 times 5 to the 6th is. So we could rewrite this. Our hint says pair 2's and 5's. We would have 2 to the 6th times 5 to the 6th times 3. And that's by the associative property, or excuse me, commutative property that says we can reorder. And then when I have two things being multiplied that have the same exponent, I can have that exponent be outside parentheses. So 2 times 5 inside the parentheses now is 10. Still have that exponent. 10 to the 6th is 10 with 6 zeros. So 1 million times 3 is 3 million. One side of a rectangle has vertices at -2, -5. So to the left 2, down 5. -9, -5. What is the length of the adjacent side if the area of the rectangle is 21 square units? So to find area, we take the base times the height. 1, 2, 3, 4, 5, 6, 7. So the length of this one is 7. 7 times what would give us 21? So the length of the adjacent side must be 3 units. 7, which is what we know, times 3 would give us 21. So then it says, find 2 possible locations for the other pair of vertices. Well, if I go 3 up from this one, they would be here. So there's 1 possible location. And if I go 3 down, it would be here. So first we have left 2, down 2. So that's -2, -2. With left 9, down 2. And then the second option for where those vertices could be is down left 2, down 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yep. Down 8 and left 9, down 8. A corner was cut from a 5-inch square. Find the area of the square, the area of the rectangle, and the area of the remaining shape. So if we look at this, if it was a square, that means that the sides were 5 by 5. So this length of the triangle here must be 4. This length of the triangle here must be 3, because 3 plus 2 would give me 5. So to find the area of the square, I would have length times width, 5 times 5, which is 25 units. Oops, and it's inches, they tell us. So 25 inches. Squared. So that's A. B says find the area of the triangle. So the area of the triangle we get from 1/2 the base, which is 4, times the height, which is 3, which is 2 times 3 is 6 inches squared. And then we want to find the area of what's left, which is this shape right here. And the hint says subtract. So basically, if we take the entire square's area and we just take away the area of this triangle, that would leave us with the area of that shape. So we have 25 minus 6 is 19 inches squared. Write 25% as a reduced fraction. I hope that you all know that 25% is the fraction 1/4. And as a decimal, you just move that decimal point 2 places to the left, so 0.25. Which form would you find most convenient to compute 25% of 24? I would say 1/4, because 24 divided by 4 is easy to do in my head. Consider the uppercase letters, X, Y, and Z. Which letter does not have reflective symmetry? So if I'm going to try my best here to replicate these. Okay, so reflective symmetry let's try again. I need different colors, I think. Reflective symmetry means that if I take this right here and I flip it left to right, it should still seem like the same letter. And because mine's not perfect like this one that the computer wrote, It looks a little bit different, but it's still recognizable as an X. So the X has reflective symmetry. Then how about the Y? If I take that one and I flip it left and right, it's still recognizable as a Y. Again, it's not perfect the way that I wrote it. So the Y has reflective symmetry. How about with a Z? If I take the Z and I flip it left to right, it now looks like an S. It is not a Z. So the Z does not have reflective symmetry. Which letter does not have rotational symmetry? Rotational symmetry means that if I take the letter and I rotate it, can I still recognize it without making all the way a full turn? If I flip the X, turn the X all the way around so that the top is now on the bottom, it still looks like an X. Let me get my Z the right way now. If I take my Z and I do the same thing where the top is now the bottom, it still looks like a Z. But if I do that with the Y, it's not a Y until I go all the way back around like that. So the Y does not have rotational symmetry. Estimate by rounding first. So 2.8 I would round to 3. 1.1 rounds to 1, 1.9 rounds to 2. Order of operations, we have to do the exponents first. So 3 squared is 9, 1 squared is 1. Do what's on top. 9 plus 1 is 10. And then 10 divided by 2 is 5. So I should say that this is about equal because that's where I start rounding. A coin is tossed and a number cube is rolled. What is the sample space for the experiment? So I'm either going to get heads or tails, and it's either going to be 1, 2, 3, 4, 5, or 6. So I could get a heads and a 1, heads and a 2, heads and a 3, heads and a 4, heads and a 5, heads and a 6, tails and 1, tails or 2, tails and 3, tails and 4, tails and 5, and tails in 6. So the sample space is just all of those listed out. So whoops. Okay, and then what is the probability of tossing a heads and rolling a 1? Well, there's only this one right here where I get a heads and a 1. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ways to do it. So the probability of heads and 1 is 1/12. How would you rearrange the numbers so that they are easier to multiply? Well, when I see a 3 in this 1/3, I know that if I get them next to each other, it's going to cancel out. So I want to get the 3 over that direction. So the first thing that I do is I flip where the 2 and the 1/3 are. And I can do that by the commutative property. Then I'm going to shift where the parentheses are, so I can do 3 times 1/3 first. And I can do that by the associative property. Three times 1/3, those are reciprocals. 3 can be written as 3/1, and then 1/3. Reciprocals, when you add them together, or multiply them together, give you 1. And that is the multiplicative inverse property. And then the last one, 1 times anything is itself, and that is the multiplicative identity property. Better just abbreviate it. Mult-ID. Find two values that make this equation true. Well, what two numbers multiply? What number, when you multiply by itself, gives you 16? Well, 4 times 4 would give you 16. But also, if you take negative 4 times negative 4, that would also give you a positive 16, because a negative times a negative is a positive. Solve using inverse operations. So in these ones, when I see that 0.9 is being added to x right now, to undo that, to isolate x, I can subtract it, because that's the opposite or inverse operation of adding. 17 minus 9 is 8. 1 minus 0 is 1. So then x is left by itself because positive 0.9 minus 0.9 is 0. X is left by itself over here, and we get 1.9, or 1.8 on that side. Right now in the 25, 0.9 is being multiplied by x. So the opposite of multiplication is division. So if I take that, whatever I do to one side, I have to do to the other. 0.9 divided by 0.9 gives me 1, and 1x is just written as x. Then I have 2.7 divided by 0.9. Move the decimal places so that my divisor is not a decimal anymore. So now 9 goes into 27 3 times. 3 times 9 is 27. So x is 3. The moon is about 250,000 miles from Earth. The moon is about how many miles from Earth? Well, 250,000, 250,000 is 250,000, because if I add 250,000 4 times, I end up with 1,000,000. Express your answer to part A in scientific notation. Well, for scientific notation, I need to have the decimal be in between the 2 and the 5, so that I have one decimal to the left of the, or one number to the left of the decimal point. And that would mean that I moved the decimal 1, 2, 3, 4, 5 places. Times 10 to the 5th. Refer to the diagram. Find the measure of angle A. Well, if you notice, this angle and then plus A make a straight line. So together they must equal 180 degrees. Well, this one's 150. 150 plus 30 would give me 180. Then, once we know that this one is 30 degrees, within a triangle, this entire triangle has to be 180. And we have 90 here for the right angle and 30 taken up. So what's left for B is 60. Sketch a circle with a diameter of 2 inches. What is the circumference of a circle with a diameter of 2 inches? Use 3.14 for pi. So to find circumference, the formula is pi times the diameter. And since we have diameter, we'll use that one. which then would be pi times 2. And they want us to approximate with 3.14. And 3.14 times 2, 314 times 2 would be 628. And then we ignored 2 decimal places, so we move that there. And then it's inches. Circumference is like perimeter, so it's just inches, not inches squared. Rafters are lengths of wood, often 2x6s or 2x8s, that support the roof. Find the length of the rafters for the building shown. So the rafter is this length, which they've given us then an entire triangle where the rafter is the hypotenuse, or C, if I'm talking about the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. So we'll call a 5, b 12, and then we'll try and figure out what c must be. 5 squared is 25, 12 squared is 144, 25 and 144 is 169, and then the square root of 169 is 13. And the other units were in feet, so this must be in feet. A smaller square is cut from a larger square. What is the area of the remaining figure? So if we look at this, if this takes up 2 inches of the 5 here, that says that this side must be 3 inches. And then if this takes up 2 inches of the 5 here, then this must be 3 inches. So one way that we could do this is to say, what was the area of the original square? So 5 times 5 is 25. And then we could say, what's the area of the cutout, which was a 3 by 3 square, as we just labeled, which is 9 inches. And then we know that it was taken away, so it was subtracted. So 16 inches squared. That's one way to figure out the area of the remaining figure. Another way would be to break up the remaining figure into shapes that we know how to find the area of. So we could do it like this. Then we have a rectangle here. That's 2 by 3. So 2 times 3 is 6 inches squared. And then we have a rectangle here, which is 5 by 2, which is 10 inches squared. We add those two together. And we get 16 inches squared again. So again, it's nice to have 2 different ways to get the same answer so that you can check your work.